The other day, for the first part of this section, we went over absolute value equations. That was stuff like the absolute value of 3x plus 2 was equal to 10. Now, you might remember when we were solving that, we looked at a positive case and a negative case to solve that kind of thing. That's because we have to look for two solutions. If you were to give it a graphical interpretation, you're looking for where 3x plus 2 is equal to 10. And those graphs cross each other at two places. So there was two solutions to our absolute value equations. But what if I turn that equation into an inequality? If I want to know where this is greater than or equal to 10, that changes things up. Now what I'm looking for is where the y coordinate is taller in the blue graph than it is for the red graph. So to kind of examine that a little bit and spot that, let's do this. Let me put a little cursor on here and move this around. And what I want to do is I want to think about, well, where is it that, this cursor is taller than the red graph? And it's going to start right there. So it's going to start right here and then move to the left. And then again over here, starting here and moving to the right. So there's really two intervals where this graph, the blue graph, is taller than the red graph. And that's going to be my solution. Now, you don't necessarily have to have a good visualization of this to be able to work these things, but maybe it's not too bad to look at things. Now, let's click here and here. The answers to my problem are going to be the intervals to the right of this. So 2.667 is really as close as decimals as you're going to get here to 8/3. So to the right of 8/3 and to the left of -4 on the x-axis. When you write your solution, it's going to look like this, at least roughly like that. There is a little typo. Maybe if you're watching this later, you can pause the video and figure out what the typo is. Or maybe we'll just do it ourselves and figure out what what's wrong with that. So, all right, let's actually work a few problems. And boy, this could be a bummer here. Oh boy. I'm out of paper. I'm absolutely all out of paper. All right, I'm gonna have to pause for a second and I'll be back. I gotta get some paper. I can't believe that. Sorry. I hate when that happens.
It was from last week.
Okay. Sorry about that. So the other day when we were solving these problems, we did 2 cases. So let's see if we can't repeat our success there. The absolute value of 3x plus 2 is greater than or equal to 10.
We can't see it.
I'm sorry. Thank you. Come on, there we go. So the absolute value of 3x plus 2 is greater than or equal to 10. Let's see if we can't mimic what we did the other day. The other day, we considered a positive case and a negative case. Let's see if we can at least get the positive case, get that going. What do you suppose the positive case would look like for these types of problems? Well, what did we do the other day when we had the positive case? It was
Just keep it the same as it is.
yeah, pretty much same as it is, except we're gonna drop the absolute value part. All right? And for the negative case, we took the opposite of what's inside. 3x plus 2 is greater than or equal to 10. Great. Let's see what happens when we solve. I can subtract 2 from both sides and then divide by 3. There's my x is greater than or equal to 8/3. If I distribute the negative sign to both terms here and then add 2, I get 3x is greater than or equal to 12. Excuse me, negative 3x is greater than or equal to 12. What happens when I divide both sides by negative 3?
You gotta flip the sign.
Ah, thanks. You got to flip the sign, so we have x is less than or equal to negative 4. So interestingly enough, you've got 2 intervals that face away from each other. Now there's one more little thing that I've got to add here. When you're doing the absolute value greater than case, it's an or. It's this or this. So down to here, it's this or this. And let's graph that and take a look at it graphically. So let's see. Here, I'll do this one in pink and this one in orange. So for this one, I want everything to the right of 8/3, including 8/3. So what kind of a dot am I going to draw at 8/3? Solid or hollow?
Solid.
Solid. Solid dot here, arrow to the right. And then over here, solid dot on negative 4, and then arrow to the left. Let's put in some numbers here. That'd be negative 4. That's our positive 8/3. And there's our answer. Now there is one more form of the answer that I could ask you for, but so far we've got the inequality, the graph. The last thing I could ask you for would be the interval notation. And for the interval notation, I've got to describe each of these intervals. So everything to the left of negative 4, including negative 4, that would be negative infinity to negative 4. Bracket or parenthesis? Bracket. Now the or part here, we're going to signify with a union. If, on a test, if you just wrote or, that's fine. And then 8/3 to infinity. Great. Now the one thing that's characteristic about your absolute value greater than case is that you're going to get 2 intervals that face like this. So look for that kind of thing in your answer. 2 intervals that face away from each other. How's that first one look? Okay with that one?
Good.
Yeah. All right. Sarah, doing all right with that one? So the way I approach these things, I try and be consistent with what we did the other day when we did our positive case and our negative case. There's 3 different types of problems that we're going to solve with absolute values. Absolute value greater than case, absolute value less than case, and absolute value equal to case. You can do the same thing in solving all of those. Now, just as kind of a reminder, that absolute value equations, or excuse me, absolute value greater than inequalities face away from each other, let's look at this one and see if we can't think of values of x that satisfy this. Now, something you take the absolute value of and is bigger than 2, you're going to find those values to the right of positive 2. Or you could also find those values to the left of negative 2. Either way, when you take absolute value or take the absolute value of a number in this range, it's going to be bigger than negative 2. So once again, you get two intervals that face away from each other. That's what you should expect when you're working on these problems, and it's a good double check of your work that you do get something like this. All right, so let's do kind of a simple one to get warmed up on ourselves. That'd be I, so example I. The absolute value of x plus 5 is greater than or equal to 7. So again, start with your positive case and your negative case. You have to consider both of them because both of them are going to contribute to the solution. Literally, if you wrote down this much, I'd give you a point just to start with. So x plus 5 is greater than or equal to 7. And then the opposite of that. When you solve, we get x is greater than or equal to 2. It is a little bit more work to solve the second inequality. We get negative x is greater than or equal to 12. Caitlin, how does that end up solving? What do we end up with when we solve for x?
Negative 12. And then you want to flip the sign.
Good. When we divide both sides by a negative, we have to flip the direction of inequality. So, perfect. Let's graph that. So like the last one, I'll do this in different colors. We've got x is greater than or equal to 2, and x is greater than, less than or equal to negative 12. These two intervals face away from each other. So at negative 12, I've got a solid dot and an arrow running to the left. At positive 2, again, I have a solid dot, this time an arrow running to the right. And that's it. That's what I expect for an absolute value greater than case. Is two intervals that face away from each other. So nice. Nice. Let's do the interval notation for that one as well, just to kind of complete this in a nice fashion. So the interval notation is going to be negative infinity to negative 12, union 2 to infinity. Hey, not bad, not bad. Okay, let's keep going with example K. No, let's see. How about example J first? Example J. Absolute value of negative 1 minus 2x is greater than 5. So a couple little trickier problems here to keep the momentum going. This one's a little bit tricky because of the negative stuff going on the inside. Let's see. Let's just attack it the way we've attacked all our absolute value problems so far. That is by working on a positive case and a negative case. So why don't you take a moment, see if you can't write down those two cases for yourself first. when I grade your tests, I always look for a positive case and a negative case. The positive case, hopefully that's a no-brainer. That's just copying this down without the absolute value. If what's inside here is positive, you don't need the absolute value. But if what's inside here is negative, you're going to take the opposite to take it outside of the absolute value. So there's your two cases. For the first one, I'll add 1 to both sides and end up with negative 2x. Negative 2x is greater than 6. To finish solving, I'm going to divide both sides by negative 2. What else happens other than getting a negative 3 on the right-hand side?
Signs flip.
Signs flip. Nice. So this, or, because remember there's an or between these things. If I distribute the negative 1, I get 1 plus 2x is greater than 5. So subtracting 1, I get 2x is greater than 4, or x is greater than 2. So one or the other. Let's see if this looks like what it should. That is two intervals that face away from each other. So on the one hand, we've got x is less than negative 3. So that's my negative 3 here. Which way am I going to draw the arrow? To the right or to the left?
Left.
Good, the left. When the variable's on the left-hand side, this arrow points in the direction, or this inequality points in the direction that you're going to draw your arrow. Thanks, Jameson. And then let's do the same over here. That's going to be a hollow dot at 2, arrow to the right. And that's it. There's your solution for your absolute value inequality. You can pick any number out of either side of this interval, or either side of these intervals, and plug it in here, and it should work. So if you wanted to go back and double check yourself with some things, you could. For instance, should 0 be a solution here? No. There's this gap in between where there's nothing. And if you put in a 0, negative 1 minus 2 times 0 is just negative 1. The absolute value of negative 1 is 1, but 1 isn't bigger than 5, so 0 should not be there. We should probably do the interval notation as well. Lauren, what's the interval notation going to look like for this one?
So I have parentheses negative infinity, comma negative 3,
Good?
with a bracket.
Bracket or parenthesis?
Would it be parentheses?
Are we including the negative 3 or not? So is that a bracket or parenthesis?
Parentheses.
Parenthesis, yeah. And then union. Keep going.
Oh, so I got, it would be also parentheses 2, comma infinity.
Mm-hmm. Good. And infinity and negative infinity always get a parenthesis. Awesome. Thank you. Let's try example K. And this one's a little funny because you get the absolute value, negative the absolute value of 4x minus 2 is less than negative 14. Now, usually when you have a negative involved with an absolute value equation or an inequality, my advice is to stop and think. But there's something we got to do before we worry about, well, should we think about this yet, or what should we do? Can anyone remember from what we did in the first part of this section with our absolute values before we started really solving?
It opens downwards on the graph.
This much would open downwards. Yes, it would be. It'd be shifted a little bit.
Get rid of the outside graph.
Yeah, you want to get the absolute value by itself first. So before we start doing your positive and negative case, we gotta get the absolute value by itself. So let's write that down. So star here, you wanna get the absolute value by itself first. So get the absolute value by itself first. Nice, Sammy. What am I going to do to get the absolute value by itself? Why isn't it by itself? Ian?
You divide it by 1 or by negative 1.
Excellent. You've got this negative out front, so we want to get rid of that negative. I'm going to divide both sides of this inequality by negative 1. Carvel, what's that going to do to my inequality? What's it going to look like after we simplify this?
It would be 4x plus 2.
Before we start worrying about what's inside here, let's take care of this here and here. Or it's kind of similar here and here. When you divide a negative by a negative, what happens?
Becomes positive.
Becomes positive. All right, so this is going to be a positive 14 on the right-hand side. On the left-hand side, again, you've got a negative divided by a negative. What happens when you divide by two negatives, or you have two negatives in a quotient? Negative divided by negative is
Positive.
positive. Great. So we get a positive absolute value over here, positive 14 here. There's one last thing that I got to take care of.
Flip the sign.
Yeah, flip the sign. Because we divided by a negative, you've got to flip the direction of the inequality. Sterling, okay with that? All right. Now we can get busy with setting up our two conditions. We've got our positive case and our negative case. So I'm just going to copy that again over here. 4x minus 2 greater than 14. Positive case and the negative case. So the positive case is going to look like this. 4x minus 2 is greater than 14. That's the easy part. Sterling, let me give you the harder part. What's the negative case going to look like for us here?
Negative 4x plus 2 equals 44.
Yeah, so you distributed right away, and that's fine. Nothing wrong with that at all. Yeah, negative 4x plus 2 is greater than 14. Perfect. Thank you, sir. So let's solve each of these. On the one hand, we get 4x is greater than 16. So x is greater than 4. On the other hand, I get negative 4x is greater than 12. Jameson, what can you tell me about x?
You gotta flip the sign for negative 12.
All right, so divided by negative 4, I get,
Negative 12. Oh, sorry, divide.
it's okay, yeah, it's all right. All right, so we're good. Remember, this is an or. So when we graph it, we're going to get both intervals. There are going to be two intervals. There's just no choice to write it. There's nothing fancy you can do here, nothing fancy I can do. You're just going to have to list both intervals. So let's graph it. Maybe if you're watching this at home later, you want to pause the video and see if you can't figure out what the graph and the interval notation looks like. For now, I've got x is greater than 4. That's going to be everything to the right of this. And x is less than negative 3. That's everything to the left there. And I get negative 3 here and 4 here. Interval notation. John, what's the interval notation look like for this last one?
Negative infinity to negative 3.
Perfect.
and then the union,
Mhm.
in parentheses, a negative or positive 4 to positive underneath.
Excellent. So all three different forms of that. Nice, nice. All right. Let me give you kind of a bonus example, and then we're gonna have to discuss a couple of kind of special cases here. So I think your handout has run out, but we'll continue kind of numbering / lettering these things as if it didn't. I'll title this one example M. Absolute value of 3x plus 4 plus 2. Let's see. Let's see, do I want to do the less than case yet? I guess we'll move into the less than case. Is less than 9. So we're moving into the less than case. Before I get busy in setting up my positive case and negative case, Shauna, what do you think I have to do before I, do the old positive case and negative case we did up here?
Let's get rid of the +2.
Yeah, let's get rid of that +2. So I get the absolute value of 3x plus 4 is less than 7. Nice. Now I'm free to set up my positive case and a negative case. So let's continue. And let's see. So the positive case and the negative case is going to be 3x plus 4 is less than 7. And negative of 3x plus 4 is also less than 7. Let's solve each of these. X is less than 1. If I distribute that negative, add 4 to both sides, and then divide by 3, I get x is greater than negative 11 over 3. You could write that as negative 3 2/3. Doesn't bother me. But there's a couple things that are going to be different about the absolute value less than case. Let's look back at our absolute value greater than case. With our absolute value greater than case, we had an or here. What do you think is going to be happening with the absolute value less than case? Yeah, it's going to be an and. So let's look at what happens when we graph this with the understanding that this is an and not an or. So we've got x is less than 1 and x is greater than negative 11/3. I'm going to graph these things in color. So do that one in orange. We'll do this one in pink. Now, what does and mean? As far as our graphs and our work with sets is concerned, what does the and mean? Are we looking to add these two things together or something different? Colby?
Those are the only possible solutions.
Think back to what we did, section 8.4. That was the prelude to this stuff. What did it mean to look at the intersection? What are we looking for when we solve this?
Where they meet.
Yeah, where they overlap, where they meet. So let's see here. We've got x is less than 1 here. So Jocelyn, solid dot or hollow dot?
Hollow.
Hollow, arrow to the
Left.
left. Good. And then somewhere to the left, I've got negative 11/3. So that's over here. And this time we're going to have a hollow dot, arrow to the right. Okay, so that's my negative 11 thirds here. Negative 11 thirds. But because I'm looking for an intersection, what's my actual final answer here? Is it like everything? Do these intersect everywhere?
No.
Is it just to the right of one or to the left of?
In between.
Ah, you're looking for where they overlap, and they overlap here. So it's the in-between part. It's negative 11 thirds to 1. Pearl, what do you think? Brackets or parentheses? Yeah, parentheses around both ends, because we're not including either endpoint. So there's your inequality, there's your graph, there's your interval notation. Got all three. So looking good. Notice that even though it's the absolute value less than case, we're still doing the same thing. We're still doing a positive and negative case. The only difference is that you're looking for the intersection, where they overlap. So the reason I teach it this way is because now you're doing the same thing for the absolute value greater than case, the absolute value less than case, and the absolute value equal to case. So there's 3 different types of problems you can solve doing the same thing. Let's do another one. Example, bless you, N. Absolute value of 4x minus 2 is less than 14. So do your positive case and your negative case. And unpause the video later when this disappears. Try and solve it, try and graph it, try and come up with the interval notation. I did both. You familiar with it? Okay. You're the first person that I've had as a student that's actually recognized it. What's that?
You say you post these?
I'm recording this video and I'll post it later.
You post these?
Yeah. Yeah. So, just so you know, my playlist has a shortcut that you can get to. I mean, you can search for me and for this class, but the shortcut is that. So, it's easy to get to that way. Okay. I'll do the negative one and then see where they overlap. So what's the solution? Four is for the greater case.
And one.
Mhm.
I see.
Okay, so our two cases, absolute value of 4x minus 2 is less than 14. The two cases turn into 4x minus 2 is less than 14, and the negative of that, 4x minus 2 is less than 14. If you wanted to just write it down as negative 4x plus 2, that is, distribute it right away, that's fine. Over here, I'll add 2 to both sides, and then divide by 4. And over here, I'll subtract 2, negative 4x is less than 12. Divided by negative 4 gives me x is greater than negative 3. So it's this and this. So you're looking for the intersection. So let's see if we can't find that. So we want everything to the right of negative 3. So that's going to be here at negative 3. Everything to the right. And then everything to the left of 4. So there, to the left. So we've got our negative 3 and 4. But the important thing to keep in mind is we're looking for the intersection. So we're looking for this and this. Where do they overlap? Where do they overlap? Yeah, from negative 3 to 4. Right in here is where they overlap. So your final answer in this case would be negative 3 to 4. That would be your answer. In interval notation, here's the inequality, here's the graph. Now, I'll throw out one more thing here for you in terms of solving these things. But I like solving it this way because it's consistent with what we've done before. In this one case, with the absolute value less than, there's a shortcut. Thing is, you got to remember to only use it for the absolute value less than case. It doesn't work for the absolute value greater than case. It just doesn't. People try it, it doesn't. Trust me on that one. So, example N, alternative. And I should put a star, only works for the absolute value less than case. With that in mind, let me rewrite the problem. 4x minus 2 is less than 14. What you're going to do is you take your 4x minus 2 and you're going to surround that with two things. You're going to have the less than 14 on one side, but the greater than negative 14 on the other side. So basically you turn this into a double inequality. So if you can do that, solving it the rest of the way is not so bad. So it's just a matter of adding 2 to all 3 parts of the inequality. You get negative 12 is less than 4x is less than 16. Then what? Yeah, divide by 4. Now when I divide by 4, do I have to reverse the direction of the inequality over here? No, because I'm dividing by positive 4. That I divide into a negative 12 doesn't change anything. And take a look what pops out. You get negative 3 is less than x is less than 4. And guess what? That's our solution. It's the exact same thing that we got over here. Negative 3 to 4. So if you like this better, great. If you like the other method better, that's fine. The other method, at least you're doing the same thing again and again with all your different problems with your absolute value equations and inequalities. Nice. Comments, do you like one versus the other? The first one, the second one? Which one are you gonna do when you do these? The first one or the second one? Colby?
That one better.
Like that one? It is more efficient. You just gotta remember to use it in the right place. Jameson, any thoughts? First way, second way?
I like the second way better, but I think I'll probably stick to the first one.
Okay, all right, good feedback. Thanks, gentlemen. There's a couple other problems that you're gonna run into when you do these kinds of inequalities online and in your homework. So let me give you a few examples of those things. So let's do example O here. I don't know if you want to copy down the first one or either of these so much as maybe you just want to memorize or just understand. I don't like the word memorize in this context. Understand the result. Just maybe sit back for a second and watch. So I've got the absolute value of 2x plus 7 is greater than or equal to negative 3. So just maybe relax and watch for a minute. You could set up your positive case and negative case, and that works out great. 2x plus 7 is greater than or equal to negative 3. Subtract 7 from both sides, and then divide by 2, and I'll get x is greater than or equal to negative 5. That's fine for the first one. If I take the negative case, I get negative of 2x minus, or 2x plus 7, greater than or equal to negative 3, negative 2x minus 7. You know, just keep on solving. Negative 2x is greater than negative, or positive 4. X is less than or equal to negative 2. There's one thing we got to remember about the absolute value greater than case. What word goes between these two? Or. So it's this or this. Now, the other day I was a little bit more consistent about doing this. When it's an or, you're just looking for what's graphed. So I'm not going to bother in this case with two different colors. I just want to graph, whatever this suggests that I do. So let me draw a little graph here for ourselves. And we've got a couple numbers here, negative 5 and negative 2. X is greater than or equal to negative 5 is going to be everything to the right. X is less than or equal to negative 2 is going to be everything to the left. So I've got this or this. What's it saying overall? What's my solution? What's graphed? Everything. Nice. Everything. Negative infinity to infinity. You're not looking for the intersection because it's an or. You're looking for what's graphed. And it's everything. But we could have kind of envisioned that. Let's look back and understand why. So if this happens, if you see something like this, you can save yourself a ton of work. When you take the absolute value of a number, you're always going to get something positive, or at the worst, 0. Is something positive or 0 always going to be greater than or equal to negative 3? Yes. You can't lose with that. Colby, give me your favorite number. Anything you want.
7.
7. 2 times 7 is 14, plus 7 is 21. The absolute value of 21, oh, that's greater than negative 3. Pick another one, like 0. 2 times 0 is 0 plus 7, absolute value of 7, still greater than. Let's pick a negative number. How about negative 10? Negative 20 plus 7 is negative 13, but then you take the absolute value of it. Absolute value of negative 13, it's bigger than negative 3. You can't miss with this one. This is a sure bet. So it's always true. Now the other fancy notation that I like for that is the script R. You don't have to remember that. That's okay. Now, let's think about this one and move it over to 2x plus 7 is less than or equal to negative 3. And this time I want us to think through the solution rather than me going all the way through this by hand. I don't want us to solve this one. I want us just to think about it. So, what do we got here? Well, the smallest that this could be is 0 or something positive. If this is 0 or positive, Can something 0 or positive be less than a -3? Nick's looking a little uncertain about this. It doesn't sound like it works to me. Can something 0, positive or 0 be less than a -3?
No solution.
No.
No solution.
No solution. So when you get these negative numbers involved in an absolute value equation or inequality, stop and think. I don't want to see all the work here for these types of problems. I just want you to recognize, oh, wait a minute, let's stop and think. This one's always going to be true. Something like this can never be true. So you'll have, one of a couple solutions, and you can check. I mean, if you try plugging in a number, let's see, you gave me 7 just a minute ago, right, Colby? So let's try plugging in 7. 2 times 7 is 14, plus 7 is 21. The absolute value of 21, that's not less than or equal to -3. It won't work. So maybe that's reminding you that there's no solution to something like this, whereas everything here works. So I don't want to see you solve those out by hand. I want to see you recognize these things, and hopefully that'll help you out on the homework too, because I know there's a few problems like that there. All right, sweet. Any other wrap up on example O there? No? Looking good, Shauna? All right, sweet. Thanks.